Hello and welcome to Math 332. This video we are going to briefly talk about the methods which is known as the Gauss-Jordan elimination method, and with that I want to talk about the concept of pivot and the concept of free variables and how do you write the general solution for the system of equations using the free variable and pivot. So let's look at this example. So suppose you have a system of equations. So you have four equations with four unknowns. The unknowns are the w, x, y, and z. So the first thing you do is to write the system of equations into this augmented matrix, and you want to reduce it, right? So the reduction procedures using the Gauss-Jordan eliminations, it says that first identify the leading one, which I call pivot, but if that confuses you, don't use that terminology as yet. So I'm not going to use that terminology while I'm actually performing the row reductions. So I'm just going to call this leading one. And then you use this as a leading one, you know that you have to eliminate this number and kill this number to make all of them 0. This is already 0, so you don't really have to do anything. So the way you do it is to, in order to make this 0 and make this 0, you perform these row operations, and then you will get all of these zeros. Okay, so once we're done with that, we are going to look at the next leading one from the second row. So in the second row, we do have a leading one, which is right here. So the procedures require us to kill off this number and kill off these numbers by doing appropriate row operations. These are the operations, these are the row operations that can do that. They can make this 0 and make this 0, sorry. To make this 0 and make this 0. Okay, so once you're done with that, you have to kind of figure out what's the next step. So next step is let's look at the next row. There's nothing here to do, okay? And also the next row, there's nothing here to do. So the question is, are we done? Is this a reduced form, or even better, this is a reduced row echelon form? So is it? Well, so you look at the leading one and have to make sure everything below this is 0, which is true, and also have to make sure everything below that this is 0 and everything above it is 0, which is true. So because of that, this is our the reduced row echelon form. Okay, so as simple as that. Now I want to introduce the terminology pivots while we are already in RREF. So if you are confused about like, hey, why do you call this pivot while you are row reducing? Don't worry about it. So when you are doing row reductions, don't use the terminology pivot, okay? Just look at the leading one and so on and so forth. So once you are in RREF, and if you read the matrix row by row from the left, okay, so you approach the matrix from the left on the first row, the first non-zero numbers, you circle it. That's what we call pivot. And when you're done with that, you move on to the second row, okay? Do it when you are in RREF. So when you're in the second row, move from your left, approaching the first non-zero number, which is this. So we call this pivot. So in this system, there are two pivots. And once you're done with that, you want to write down the solutions. So once you have this pivot, means that we can write down what W is and what X is. Okay. So, but forget about that. Just follow these same procedures. Once you have the RREF, then you try to write down your W, X, Y, and Z, and try to figure out what are your W, X, Y, and Z. So look at the W. You can write W as -1. Okay, move this thing across, that will give you plus y, and then give you -2z. All right, so we're done with the W. So we're done with the first row. So let's look at the second row. So the second row tells you about x. So what is x? X is the 3 right here, and then move this thing across, so you have -2y plus 3z. So we're done, right? So what is the third row tries to tell you? They tells you nothing, so there's no information here. Same thing with the fourth row, it tells you nothing. So this is you have no information on y and z, and these are actually the free variable. You are actually free to vary them. So these are the free variable, the y and the z. Okay, so you can rewrite all this thing into rewrite into the vectors form. So this is a w, x, y, and z. These are the constants, -1 and 3 right here, 0, 0. These are the things that are related to y. So yeah, before I forgot, the free variable, you can rename it as y equal to y, and then z equal to z. These are the free variable. Okay, so sorry about that. And so look at those that are related to y, which is here. So you have the 1, -2 and the 1, and then you have a 0. And look at the things that's related to z. So this is the 2, -2, this is a 3, this is 0, this is 1, and this is what we call the general solutions. So this is what we call the general solutions of the system of equation, and this is also what we refer to as a particular solutions. It's a particular solutions. Okay, now, okay, so that's how we uses the concept of pivots and free variable in writing down the general solution of a system of equations. Okay, so one more example where we are still going to talk about the reductions, and after that we're just going to concentrate how do you interpret your row reduced echelon form or reduced row echelon form. Okay, so before we do that, let's look at one more reductions. Okay, one more reduction. So let's look at the system of equations. It's already put into the matrix form, the augmented matrix form. So if you want to do the row reductions, so using the Gauss-Jordan method, so you look at the leading one and you try to make sure everything below is 0. So it's already done, so we don't have to do anything. We have to move to the second one now. So you look at the second row, and the first time you hit a non-zero number, that is the leading numbers that you want to use to kill off this number. Now, because this is 2, so it's difficult to use that, so the convention is that, hey, let's make it to 1. So by dividing the entire second row by 2, you will have that. So now you're going to use this to kill off this. We can do that using this row operation, so everything is killed. So then you're done with the second row, so you move on to the third, right? So you move on to the third row. So the third row is basically just this equal to this, so it's pretty easy. There's nothing you can do on the third row. This is the next leading one, so you're kind of done with that. So you have the first leading one, the second leading one, and the third leading one. Okay, sorry. The first leading one, the second leading one, and the third leading one. Now, in order to make it the RREF, you have to use this leading one and kill off this number and kill off this number. And this can be done by using these operations. And so once you're done with that, in order to qualify this as the RREF, you also have to kill this number. This is the leading one, this is the leading one, this is the leading one. Everything below it has to be 0, below it 0, below it 0, above it 0. So above it has to be 0, so -3 has to die. Sorry, it has to go away. Okay, so in order to do that, we do these row operations to make this 0. So it's gone. It's gone, 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 0, 0, 0. Okay, so this is now, so this is what, once you're done with this is the RREF, okay? Reduced row echelon form. Now, so if you have trouble figure out what are the pivots and you are confused, it's like you are worried too much about like, hey, what are the pivots here, here, here? So if you without that terminology pivots, I'm pretty sure you can still row reduce. So my suggestions, if you are having that problem, is to forget about that terminology while you are row reducing it. You only think about pivots when you have RREF. Like in this case, this pivot, pivot, pivot. Okay? And let's try to write down the solutions. Pivots kind of give you the information about, hey, we should be able to write down what x1 is. Hey, we should be able to write down what x2 is. Same thing here. Hey, we should be able to write down what x5 is. So let's do that. x1, x2, x3, x4, x5. Let's look at what are the information that we can obtain from the first row. So, okay, from this pivot, we know that we can write x1 as the -24, move all this thing across, move this thing across, move this thing across, give you plus 2x3 minus 3x4. So we are done with that. Once you are done with the first row, we're moving to the second row. Okay, so when you move to the second row, you actually have information on x2. You can write x2 as -7. Again, move this thing across and move this thing across, give you plus 2x3 minus 2x4. Okay, so once you are done with the second row, move to the third one. So the third row, what does it tell you? Well, it tells you that x5 has to be 4. x5 cannot be 3. x5 is really 4. This equation really reads x5 equal to 4. So x5 equal to 4. So what are the things that is left behind is this x3 and x4. The things that's left behind, these are the things that we can name it as x3 equal to x3, x4 equal to x4, and these are the free variable. They are free to vary and generate infinitely many solutions for the system of equations. So you can rewrite all this thing into a matrix form, in the vectors form, as a column vectors, and you can collect all the constants, coefficients. These are the particular solutions. You can collect all those things, negative 24, negative 74, and pick up all the things that have x3 on it, and right here, and pick up everything that has x4 on it, and right here. And these are the general solutions with two free variables. As simple as that. Again, let me say that one more time. If you have been trouble with the concept of pivot, forget about using that terminology when you're row reducing it. You know how to row reduce a matrix with or without these terminologies. So forget about it. You only use the pivots while you are looking at RREF. If you have that trouble, just look at the RREF and figure out the pivots. Okay, so for example, and also, by the way, because you can use calculator, and so a lot of time, when you do the row operation, you don't even see this. You don't do this, okay? You don't see what happens to the Gauss-Jordan methods. Once you put into the system, into the calculator, and ask them to compute the RREF, this is the thing that you will see. So once you have this, forget about how do you get it. Forget about what the row operations. Forget about the process. This is the end result, and you should be able to write down the solution for this. So this is the RREF matrix for the system of equations with unknown x1, x2, x3, x4, and x5. So we have 5 unknown, 4 equations. So this is already RREF. So let's figure out the pivots. So this is the leading one. That's a pivot. Reading from here, row by row. Do it row by row. This is the next one. This is the next one. This is the next one. Okay, so once you have identified this, write down this x1, x2, x3, x4, x5, and figure out. Okay, figure out what is x1. So x1 can be obtained from here. You can see that x1 is negative 2x3, and that's it. And then move on. So this is the first row. We're done with that. Okay, look at the second row. The second row will give you x2 equals to minus x3. Okay, write that right here, move it to the other side, become negative. Okay, then we're done with that. Okay, moving on. So the third row tells you information about x4, not x3. Be careful. Okay, it tells you information about x4, not x3. So x3 we have no idea, but this third row basically tells you that x4 is 0. x4 is 0. Okay, and then move. After you're done with that, move to the next row. So this one tells you that the x5 cannot be anything. It has to be 0. x5 go to 0, and that's it. So this is the unknown. This is the free variable. So what is x3? x3 can be free. x3 can be set as x3, and this is the free variable. That's how you do it. So that's the free variable, and then you can write all this thing into a matrix, a vector form, and you can get it from right here. You can see that there's only one free variable. Okay, misconception number 1 is that you thought that it will give you x1, x2, x3, x4, x5. No, like for example, in this case, the third row doesn't give you anything about the x3. They give you about x4. You can see this is x4. This is the coefficient for x4. This x4 is 0. This x5 is 0. Okay, now this is very critical. If you don't know how to do this, you're basically going to fail this class, because this is the thing that we do day in and day out. Okay, so that's how you do it. Now these are all the examples. I'm pretty sure that you can refer to the solution and figure out the rest. So the solutions can be found here. All right, so in your homework problems, you're going to have a lot of all these questions where you have to row reduce either by hand or testing out with your calculator. You also need to know how to use a calculator. If you're not using it in the exam, you might lose a lot of time by row reducing and get all kind of weird numbers. So you will be asked to write down all the solutions in this form. So when they say find the general solutions, identify clearly which are the free variables. So these are the free variables. Write down the solution like this. Write down your 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 solution like this. Either have to perform the row reduction by hand, or you have to use a calculator. Now, so remember, this is already done. There is no operation on it. You do a lot of row operation to get to this place. You do a row operation to get to this place. So once you are looking at this matrix, you are not doing any operation. You just read, okay? You just read out the solution. To read out the solution, you don't have to do anything special. No row reduction here. It's already done. So read out the solution, and that's it. Okay, so you just read out the solutions. Read out the solution, read out the solutions. This is already RREF. You don't have to do row operation on this kind of stuff anymore. Okay, cool. Right, so do your homework, and I'll see you next Tuesday.